Hello there, I'm Thomas Hatsios, I'm an American pilot flying the Boeing 787-900 to nice flight from Zurich International Airport. We're going to be flying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 1449, let's localize and landing. So now I'm in the cockpit for the pre-takeoff preparation of the quality wings. Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments, the displays and the functions of the Boeing 787-900 aircraft. I'm going to start with the primary flight display. That displays the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the vertical rate of climb and descent of the aircraft in 10 hundreds of thoughts feet per minute, of the steepness of the trigonometric angles increase. We can climb and descend. We have also the artificial horizon with the altitude indicator, pitch flattery decrease and bank angle decrease. Also the Lszh localizer, the instrument landing system of the airport runway, so we use for takeoff and for landing. And we have the threshold antennas that transmit radio frequency that is unique for each runway, and heading, magnetic north pole heading we use for this runway alignment. So we have the onboard antennas of the aircraft that receive the Lszh localizer radio frequency. We have to tune its time for a separate radio frequency for either runway we use for takeoff and landing. And also set the heading in the autopilot panel. So we have the horizontal localizer, the vertical glide slope or angle of approach. Also the Lszh localizer crossbars displayed in the primary flight display. We have also the flight director crossbars in the primary flight display for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode and at zero with the autopilot and the autothrottle. Later on vertical navigation modes. We have also the edge side horizontal situation indicator, the magnetic heading and track data created display of the flight plan. You can see later the flight plan I'm gonna create using the flight management computer. I will need to all the data for this flight, and it's gonna be shown with a purple Mazera line connected with the waypoints one by one. So we have also the navigation display. You can see the navigation display. We have the terrain and weather reflection from the weather radar. You can see the terrain elevation displayed with red, green, yellow color depending on the distance the terrain is away from the aircraft, and the altitude difference as we fly or when we are on the ground. Also we can see the lakes, the rivers and the sea with the blue. We have the airports where they are located in the terrain map, the GPS position of the aircraft, and also the magnetic north pole, the geographic north pole, and the magnetic variation where we are on the world. So you can see the airports with the 4-letter account names, the runways we use for takeoff and for landing, and the taxiways. So we have the airport maps also. We have also the board stations and the Fs and the Bs, the navigation aids, the nav aids, also the waypoints, which are horizontal, vertical navigation fixes and altitude and speed constraints. So the waypoints, we're gonna select some waypoints from the flight management computer later, one by one. It's gonna be connected with the purple line you see over here. So we have the flight management computer. You can see the navigation display, the horizontal and the vertical. Also the primary flight display over here, the flight mode demonstrator, the edge side, the engines indication, the autopilot flight director system panel, the thrust levers over here, the flight controls of the aircraft. So also all the systems. Also in navigation display you can see we have the display of other aircraft that fly around our own aircraft using the transponder, the DSP ADC transmitter receiver that transmits a radio frequency to other aircraft and the air traffic control and receives from other aircraft. You can calculate with its computer using the radio frequency difference, the other aircraft distance from our aircraft, the altitude difference in hundreds and thousands of feet above or below our aircraft. You can also calculate whether the other aircraft is climbing or descending with respect to our aircraft. You can also calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning from the TCAS system, the traffic collision and advisory system. We have an incoming collision in the air, so we're gonna make an avoidance maneuver in the air using the TICA system on the advisory if we have an incoming collision with another aircraft. Also, the TICA, the transporter, and the TICA system can calculate and display other aircraft with the diamond shape in the navigation display with an arrow up and arrow down symbol if they climb or descend. Also the altitude difference with a plus or minus sign next to it, and it can show us up to 40 nautical miles or 72 kilometers other aircraft in the air or in a 360 degrees radial. So it can show us also aircraft in the ground, in the taxiways, runways of the airport, the airplanes. So we have other systems also to see. I'm gonna show you the computer here that I have, also the mouse pad that I'm using here, the keyboard I need for to input all the data we have here. So we have the side stick, also the load stick, extreme 3D, so we can climb, we can descend, we can make turns to the right, to the left using control wheel, the rudder pedals over here. So we can use the rudder pedals of the Boeing 787 or any airliner aircraft to control the vertical tail, the rudder. Also the nose wheel steering is reconnected with the rudder pedals, you will see. So we climb, we descend, the side stick back and forth for the yoke of the Boeing aircraft. Also the control wheel like this. Also we have the horizontal tail trim stabilizer over here. We can trim the elevator as we fly. So this way we trim the elevator of the aircraft up, we pitch the aircraft nose up, and this way we trim the elevator down, we pitch the aircraft nose down. So this is the elevator trim system, manual trim. You can see how many degrees you pitch up the aircraft, you trim the elevator up or down over here in the display. Also you can see the elevator over here is the left and the right horizontal elevator. So when we move the side stick or the yoke of an aircraft for climb descent, you can see the elevator moving. We have also the elevator trim. We can trim the stabilizer of the elevator using the trim wheel in some aircraft, or the stabilizer switch like in the Boeing 787. We have the two switches over here, one for the normal manual over here that I show you. You can see how many degrees we can set the manual trim switch like this, trim the elevator up or trim the elevator down, and pitch the nose down or pitch the nose up. Puts also we can use the control wheel like this for controlling left and right turns. Also for climb and descent, moving the control column of the aircraft. So hope you like the way it functions. As you can see, so you can see the tag here, it says elevator trim, left click down, right click up like this. So you can read the elevator over here, trim, left click down or right click up. This is very clear. Elevator click, left click down, right click up, as you can see. So this way we trim the elevator up, it's the nose aircraft of the aircraft up, and this way we trim the elevator down, we pitch the aircraft down. So you can see this switch is moving back up and down. Also you can see we have the autopilot disengage switch here, the head up declutter, the flap speed. Also we have the manual, we have an aircraft is coming for landing over here. As you can see, a Boeing 737-800. Here it is. Just touchdown on the runway. So we're gonna see also we have the stabilizer trim over here, the flaps position. As you can see, rudder trim over here, landing gear, extend and retract over here, alternate gear over here, lock override, the retract switch for the landing gear. Also So you see the stabilizer trim is 3.75 degrees right now. It's at the green button is set for takeoff limit. So we have the white limit, it's the maximum extend or retract nose up or nose down, and also the green limit is for takeoff position. So we have also the ensigns, left and right ensign. The rudder trim is 0 deflection, all the stabilizer trim. Also the cabin pressurization system, you can see the outflow valves position, open and close, cabin altitude, rate of climb descent, differential pressure will go 7.8 psi of pressurization for inside the aircraft. When we climb about 45,000 feet, the altitude of the cabin will be 6, 7 or 8,000 landing altitude. So you see now we can use also over here in the overhead panel we have the pressurization system. You can see over here pressurization. So we use the outflow valves like this in the manual, open and close, climb, descend like this, or in the pressurized the aircraft on climb, descend, and we use in the auto. So we have bleeder for cabin pressurization from the engines or the APU. We're gonna need the APU also to start the engines. Also hydraulic fluid tanks pressurization, we can engine anti-ice, oxygen inside the aircraft. When flying we need pressurizer from the engines. So we have also a couple more things to see here. So we have also the alternate pitch string here. You pitch up the aircraft nose when you fly by trimming the elevator up this way, or trimming the elevator down. You pitch the nose aircraft down. We have also the parking brakes here, as you can see, parking brakes pull or retract. So we use the trim switch, alternate and normal like this. You see how many degrees we will set the elevator, both left and right elevator like this. Over here we will display right now. Now we have 4 degrees, so we change, we pitched up a little bit from 3.75. It's a little bit closer to the limit for takeoff now from the flight management computer. Also we have the cutoff switch over here. You can see cutoff for the stabilizer left and right. You can see either left or right, or both of them together. So this is for the Boeing aircraft only, the stabilizer trim cutoff. So if we have a failure, because this is a fly-by-wire, the Boeing 787 is a fly-by-wire aircraft. It has a flight control computers on board that control the aircraft in flight. It's a flight control system. So we have a failure from a hydraulic system that will affect the motors that control the elevators up and down, or the stabilizer trim motors. It will degrade the flight control computers from normal to alternate or direct mode or mechanical backups, as like in the Airbus aircraft. The Boeing 777 and the Boeing 787 have similar modes in flight. So we have to look over here. You can see here we have the hydraulics system, left and right engine, primary demand, electric C1 and C2. Also you can see the flight control computers, primary in the auto position. So we have to come here, we leave the flight control computers in the auto. We have to come down here if we have a failure. We're gonna lose the auto trim system. This fly-by-wire aircraft, it has its auto trim. You can trim the elevator or the stabilizer automatically like the other Boeing aircraft and the Airbus aircraft in the air. So if we have failure, it will degrade the flight control computers. We're gonna lose the autopilot, and we're gonna have to come down here. This is for Boeing 737, Boeing 747, Boeing 757, Boeing 767, Boeing 777, Boeing 787. You open this red guarded switch over here. These two switches from normal to cut off, as you can see. and then you flying only with the manual trim without the autopilot with manual flight control system. As you can see, very easy. You see nose up and nose down for the trim. So I'm gonna show you a little bit more of the flight controls now, also the outside view, also a little bit of the displays, couple of explanation about the displays. Here you can see the primary flight display, what it displays, also the navigation display we need later for flying the aircraft. So you can see we have the airspeed indicator, the airspeed selected from the autopilot, flight director system panel, the artificial horizon, the altitude indicator, the pitch ladder. We decrease the barometric altitude above the sea level, the vertical rate of climb descent of the aircraft. So the needle moves up 500, 1000, 1500, 2000, 3000, 6000 feet when we climb or when we descend. Also you can see the barometric altitude set right now is 39.90 degrees of mercury for this altitude above the sea level. 1430 feet in the Swiss Alps. So we set the barometric altitude over here from the FS panel, electronic flight instrument panel. We can set inches of mercury or hectopascals. So right now it's 39.92 inches of mercury or 1013 hectopascals. You can see bar set, so if we increase or decrease the value, so it's a different barometric altitude over here. You can see 29.92, and this will affect the barometric altitude here display. So we have also the pitot dynamic for the airspeed tube, and also the static for the altitude and the vertical rate of climb descent. We have the pitch ladder 5, 2.5, 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 30 degrees for pitch up and pitch down. Also the bank roll in the air like 5, 10, 20, 35, 45, 67 degrees left and right turn. Radio altitude above the ground level, the wings level of the aircraft, and the flight director crossbars, the HSI down here. Also you can see over here we have the navigation display. You can see the terrain map, the terrain elevation with red, green, yellow colors, also the airports. So you can see here is EDTL, you can see 40 nautical miles, 20, 60, 80. So this map right now is 80 nautical miles. We can set the map range and also magnetic heading, other settings from here. We can set the range, plan, menu, weather radar, traffic on the display, terrain, accept, cancel, reset some warnings. We can set the heading over here, the altitude displayed in the vertical display, the airspeed for the primary flight display from the autopilot. So we have systems CGU info, checklist, communication, navigation display, ACAS, sensing, set, cancel, reset. So you can see the autopilot here settings. We have the airspeed selected over here, to throttle left and right, autopilot engaged and disengaged, flight director, heading, vertical rate of climb descent, and the altitude. We're gonna see later the autopilot, how to use it. So we have here the navigation display, couple more minutes, the terrain. Also you can see our own airport where the aircraft is located right now. We're gonna see later more detail. Also you can see the elevation above the ground where we fly. Right now 18 nautical miles. You can see some terrain. You can see the altitude selected here, 10,000 feet. So we set a little bit further away. You're gonna see more airports. You're gonna see Germany over here, France, and Switzerland down here. So we'll look closer. We're gonna see some bumps over here. Is the terrain over here, some mountains in front of us, 10 nautical miles, 5.5 nautical miles. You can see the aircraft where it is right now, 1,400 feet on the terrain. So in front of us we have some mountains. You can look up over here when you fly. So we are like this, DTL. So we have flight mode annunciator, takeoff, ground right now. Also the we have over here in the engines indication. I will show you that is controlled by the FAREX, the N1 exhaust gas temperature, N2 fuel flow, oil pressure, oil temperature, quantity vibration of the N2 stage of the engine. So we have gross weight for takeoff, fuel on board and fuel temperature, flight management computer, and the mouse pad for the computer. The thrust levers over here, you can control all the thrust needed. So we use a full takeoff thrust like this. You will see, will display over here some warnings will not configure for takeoff, as you can see. So we use idle thrust again. We have the thrust reverse over here, the left and the right thrust lever, the other throttle disengage the takeoff ground. We have also the fuel control, left and right engine, fuel flow, the fire extinguishers, left and right engine, pull out and switch, transporter, radio management panel, radar trim over here, the speed brakes over here, externally track like this, also the flaps position, you see over there in the display how many degrees of flaps we set. So we set maximum extender right now. So this is all the navigation instruments we need to know for this moment. So I will talk to you now about Newton's physics, aeronautical and aerospace engineering, the Bernoulli theory of fluids, and we need to know the air transport pilot theory and the commercial pilot theory, the TPL and the CPL. So we need to know aerodynamics and flight dynamics and some theory for flying the aircraft. I will show you the outside view of the aircraft for this, and it takes a couple of minutes. So you can see here the outside view of the aircraft. You can see the aircraft wings hold the weight of the aircraft when the aircraft is flying. The weight is divided over the surface area of the wings, because the wings, when the aircraft is moving forward, it produces aerodynamic lift that acts over here, the center of pressure, where the engines are positioned. So we have the thrust vectors from the jet engines that move all the jet aircraft forward. As you can see, the propulsion system. So when we fly the aircraft below, over here you can see the airflow is moving slower, so we have higher pressure, which pressurizes the aircraft wings and weighs out into the air. Also the top surface of the wings, you can see we have lower pressure because of the curvature, because the airflow is moving faster. That sucks the aircraft weight and wings up into the air. Also you can see we have the left and the right wing fuel tank, 30% in each one, the center tank. So we have the fuel booster pumps over here that feed both engines, jet engines. So we have the fuel flow is coming down here into the engines for the combustion chamber. We have the low and high pressure. We have the high pressure compressor and turbine in the back, and the high speed starter and stuff, and the low pressure compressor and turbine in the front, and the front fan. Also the thrust reversers over here. So you can see we have two flows over here. One is high speed from the inner core, from the exhaust of the engines over here, and the other one is lower airspeed, is the bypasser from the front fans, as you can see, of the jet aircraft, both engines. So we have also pressurizer from the engines for cabin pressurization. It's coming here to the manifold. We can engine out the ice, is returned back, oxygen and other systems, hydraulic fluid tanks pressurization. So we have here the main aerodynamic cord where the maximum aerodynamic lift occurs. Also the center of pressure is moving back and forth, and the top surface of the wings, also the airflow becomes detached when we fly, and the stall begins. So when we stall the aircraft, we have to pay attention. We need to push the side stick down, or the yoke, and advance the thrust levers to increase the airspeed. So this is the stall avoidance, and you see when we fly the airspeed below the airspeed tape and the airspeed, you will see a red and yellow indication is the stall speed. so we need to avoid it with the angle of stall in the air. So we have over here also in aerodynamic cord is also the center of gravity here that acts down here over the rudder, the vertical stabilizer. So we need to use the rudder for flying left and right turns for stability in the air. Also when takeoff and land, we can use the rudder together with the forward nose wheel to control the aircraft. We can use only the nose wheel if we need using the tiller. So we have the rudder pedals here. You can see we can deflect them like this. You can see how much deflection we need want to achieve. Hope you have a good view of the rudder pedals. So both the rudder pedals are interconnected, both sides, also the other flight controls in the Boeing aircraft. So you can see from 0 knots up to 45 knots or 72 kilometers an hour. 45 knots, we have the forward nozzle, can deflect up to 76 degrees left and right. So above 45 knots or 72 kilometers an hour, the rudder becomes aerodynamically effective in takeoff. So the computer will limit automatically, wouldn't need to do nothing, the forward nozzle from 76 degrees down to 7.6 degrees left and right deflection. Then above 80 knots or 144 kilometers an hour in takeoff, the computer will limit automatically, will lock the forward nozzle to 0 deflection or a small deflection like half or 1 degree. So we have only the rudder above 144 kilometers an hour or 80 knots in takeoff. Also when we land it's the inverse, we're slowing down the aircraft and then the computer automatically will activate the forward nozzle. So this is for the rudder pedals deflection. What they do, also we have the toe brakes in the top surface. So this is all vertical. We have this axis is from wingtip to wingtip. It's the pitch axis. So we use the side stick in the Airbus to climb, descend, take the weight up, take the weight down. We saw the tail, the elevator, as you can see. Also in the Boeing we have the control column like this: climb, descend, take the weight up, climb, take the weight down, descend. So it's easy to remember. Same flight control function, no difference. Also we have over here the ailerons and the spoilers, as you can see. We have one more axis from nose to tail, is the longitudinal axis or all axis. We can use ailerons, spoilers, left and right side stick in the Airbus like this. In the Boeing, so we use the differential air pressure between the left and right wing like this to make the aircraft roll either left or right. You can see spoilers all extended and the flaps and the speed brakes and the slats extended. So we use a control wheel in the Boeing to make left and right turns like this, very easy to remember, no difference. So all flight controls together, coordinated flight like this. Also the thrust levers over here, we use the thrust, and we have the horizontal trim stabilizer. So this what we need to know. I will show you one more view now of the flight controls of the Boeing 787, and I will show you the flight management computer, so you will see now this one. I hope you're gonna like it. You can see again my computer, how I use the flight controls of the Boeing 787 over here. The side stick that I have, that is a dedicated to the Airbus, so you will see also a nicer view of the screen together with that. So you can see we can climb and descend like this, side stick back and forth. This is identical to the Airbus side stick, as you can see. So climb and descend, make turns to the right, make turns to the left. No difference between the Boeing and the Airbus flight control system, all the same. Just one half the side stick, one half the yoke. So we climb, descend, make turns to the right, make turns to the left, use horizontal trim stabilizer, and also I use the thrust levers over here. As you can see, we have the thrust command by the engines over here. You can see how much percent of the engines we want or really need to use. You will see displayed. So it's very easy to use. Hope you like it. My flight control system like this. You can see also we have the autopilot disengaged for the Airbus. The side stick priority button. We can take either side priority, and also the push to talk button. So it's identical to the Airbus, as you can see. Airbus technology. So climb the same, it turns right, left, rudder pedals, coordinated flight. Also the outside view for this. So we climb, descend, make turns, rudder pedals. We see how fast it is. Climb, descend, back and forth the side stick. And also ailerons and spoilers over here, left and right. So climb, rudder. So this is all for the flight controls lesson right now. We go now for the flight management computer, as you're gonna see now. So we have the flight management computer left now, and a couple more things before going into flight. You're gonna see now the flight management computer, a couple more things. So you're gonna see now I will use this mouse pad and the keyboards over here, and I will set up the flight management computer. I will create a flight plan, the autopilot also can follow in flight, so stay with me for the rest. We have over here the display. You can see the mouse pad you can use here with the touch screen. So we input through the keyboards here also. So the index, you can set the position, takeoff, approach, flight plans. So we go here for this view actually. So this view you can see also. We're gonna make it faster for this control over here. So we have identity. It's a Boeing 787 the aircraft with the NX engines, position, Lszh airport. We can align the IRS, the inertial reference system, with the longitude and the latitude, the coordinates of the aircraft with the laser gyroscopes and the magnetic north pole, reserve fuel, zero fuel, weight, fuel on board, gross weight for takeoff, reserve fuel, gross altitude, cost index, fuel freezing temperature, cruising center of gravity. So we set the route, origin, Lszh airport over here, origin, destination over here again, copy paste, clear, runway 14, set departures over here, select runway. We can select runway 10, 14, 16, 28, 34, 32. So we select runway 14, France, Zurich 12, have seats. So we have the first waypoints created, arrival. We can use runway 16, 28, 34, 14, ILS, 14, ILS, 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we use ILS 14, Transamity over here. And the stars is other terminal arrival waypoints and fixes. We use Negrio 1 Alpha. So we have the route is displayed with blue, is not yet activated. You can see one waypoint by another. Cancel the discontinuity. Initialize here. Reserve fuel, fuel on board, cruising altitude 35,300, cost index, gross weight for takeoff, fuel freezing temperature over here, cruising center of gravity. So we can press the green button over here. It will show us the active route now is activated. So we have first waypoint after takeoff, airspeed 250 knots, 1900, make a few waypoints, 1, 2, 3, 5, 6 nautical miles away is the Zui, 200, 301 knots, 6000 alpha. heading 052, then Nigria 071, heading 36 nautical miles from Zui, 301 knots, flight level 22,200, make a right turn, 12 nautical miles, Mativ, then Zui again, 9 nautical miles, Zurich 701, approach here for landing. So we descend here and approach, make a left turn, Osnem runway 14, we align with the Lszh localizer over here. So this is what the autopilot we follow if we connect it. Flaps for takeoff, center of gravity trim, runway position, takeoff, speed V1, V-rotate V2 for this gross weight. So we have route, departure, arrivals, alternate, VNAV, progress, FMC communication, hold, we can hold over a waypoint, set our radial fix, also navigation, tune IADF, VOR Lszh localizer if we need to tune either. So we can set over here running glides. We're gonna turn on the APU right now. I'll show you on the start. So we're gonna see a little bit here the flight plan we created. So you can see the flight plan. The displays are a bit different. You can see the localizer now, also the glide slope. So we can see the flight director also. So you can see the purple line is the waypoints and the flight plan we have to follow. In the vertical also, when climbing the aircraft, you're gonna see the terrain below us. You can see the runway, also the terrain we're gonna have in front of us. So we will look a little bit closer like this. You can see the airport map like this. Over here you can see the whole airport over here displayed the Zurich airport. Also we can see our position over here, the runway, the taxiway we are like right now in front of us, the runway we're gonna use for takeoff, and the other runway. So you can see in front of you, this is the taxiway displayed here in the navigation display, also the runway. So look outside, you can see same like in the GPS and the terrain map, the terrain in front of you, the runways. We can guide the aircraft even without with clouding condition, with fog or night, with no visibility. So we can also have this map over here, the plan. So map centering over here. We can see a little further away with this view. You see more of the flight plan. I've created some airports further away. So we go now for the overhead panel. We have a few more minutes left over here. So we have the left and right engine driving IGT 100 200 volts for 100 Hz frequency. The APU is running. We need to start the engines without the battery. Primary flight control computers in the auto position. Air data computer for the pitot static, laser gyros, flight control surfaces, battery, passenger oxygen, towing power, FD door over here, window heat over here, rammer turbine, backup hydraulic turbine in the air, primary demand, left and right engine driving, electric C1 and C2. So we turn off, you see what it displays a fold. So we need to turn back on, then to the auto position like this. You see the fold will disappear. We have the wing and engine RDIs over here on our auto position like this. For this flight, also cabin pressurization. When we climb, descend manual, pressurize the cabin, have flow valves open and close. So in the auto we don't need to do nothing. So we have pressurized air from the engines for cabin pressurization, oxygen, weakened engine RDIs over here, hydraulic fluid tanks pressurization, and other systems, ventilation. So we have here, you can see the recorders, cargo and APU fire over here, electronic engine control for the engines. With the auto start, you can start the engines like this. Also we have the fuel, we can dump some fuel in flight, arm this, select the nozzles and how much fuel to remain. We have the crossfeed, left and right wing, fuel tank, center tank. The crossfeed valve, we can balance the fuel between the left and right wing, like this, or feed either engine with other pump or either tank. So we have the fuel systems, like this. So we go back here, we need to see only the systems here in the display. So we have the systems displayed, as you can see. So you can see the hydraulics, the APU, oxygen, liquid cooling, also the electric over here, left and right. The APU is running, the contactors drive, generator drive, the voltage of the battery, charge and discharge, battery and APU battery, the hydraulics, where the hydraulic fluid goes, which system use hydraulic fluid over here. You can see flaps, right reversal. So we have primary demand, engine driving, electric C1 and C2, isolation valve, set-off valve, also pressure 5100 psi, and the quantity of the hydraulic fluid. We have the fuel on board. You can see the left and the right wing, fuel tank. Over here the center tank, we have 11,000 total 34,000. When high pressure fuel valves open and feed both engines from the center of the wing tanks. The APU is fed from left wing using the DC motor. The crossfeed valve, we would only feed either engine with other pump or either tank. Also the fatics that control the engine's function, the fuel flow, also control. We can see the minimum fuel temperature down here, below which the fuel will freeze in flight. So the fatics control the transfer of the fuel with high altitudes where it's freezing from the left and the right wing into the engine components to heat up the fuel, then to transfer the fuel back to the left and the right wing fuel tank or the center tank. So you can see the minimum fuel temperature below which the fuel will freeze over here in flight is minus 37 degrees. The fuel temperature right now is minus 6. So we need to pay attention. This is automatic. Also the lubricant and the oil. We don't need to do nothing from the fatics. Also air pressurizer from the engines, cabin pressurization, oxygen. Doors are closed, the cabin can be pressurized, the gear, temperature of the brakes, and pressure of the tires. Also flight controls over here. You can see the deflections left and right, wing climb, descent, rudder pedals like this. So we have FX display like this, status, maintenance over here, circuit breakers. So this is all we need to do. The flight controls, as you can see, it's the last thing we need to know. And we have like this climb, descent. This is the deflections. We need to go over here, systems, checklist, normal menu, before start, after start, descent, approach, landing, what we do. Also navigation display, and we need to restart the engines very fast. So we turn off both fuel control over here, fuel flow to the off position. So you're gonna see here the engines will display the fault. We have all displays are working, the electric is working because of the APU right now. So the engines are going out. You can see the yellow warnings if we look outside. We need to restart the engines like this. So we go in the overhead panel. You see the electric is working because of the APU. The auxiliary power unit is running. So we restart over here. Both auto start. Both auto start. So you can see the auto start. Now we admit the pressurizer from the APU into the engines, left and right engines, so above to 80%. You can see the N2 is the high speed starters have high pressure compression to one of the 200 engine. The N1 with low speed starters have low pressure compression to one of the 200 engine. Exhaust gas temperature, fuel flow, oil pressure, oil temperature, quantity and vibration of the N2 stages of the engine. So now we have enough pressurizer to start the fuel flow and the fuel combustion. So we let the fuel valves open into the round position. So you see The auto start is coming on. So you can see the engines are roaring. You can see also outside. So the auto start, the yellow message is going off. At 62% we have running engines. So we're gonna go for takeoff like this. We need only set flaps for takeoff, speed brakes armed over here, and set the autopilot a couple of minutes more. So we have the LNAV and the VNAV, flight director off, this engages this mode. So we set auto throttle left and right on and off, autopilot disengage, the airspeed like this. So we're gonna set the airspeed heading bank angle limit. So we're gonna set heading magnetic north pole 136 degrees. Vertical speed, so we can set 0 like this. You can see 0. We can descend, you will see minus in front of the numbers. So we climb the other way, the slider, you will see a plus. So altitude set thousands like this and hundreds. So we have already the autopilot brief takeoff settings. We can go for takeoff, as you can see. Parking brakes off, advance the thrust levers. We take the clearance from the air traffic control. So we take clearance from the air traffic control for the takeoff. We taxi into the runway position like this. And use the tiller and the rudder pedals, so the runway is open for us. There is no other aircraft coming in. We align here with the center line. So this is Thomas Hatsios, German American pilot flying the Boeing 787. We just start the takeoff with the Boeing 787. I will advance the thrust levers. We enter the Retiro airport, so stay with me until the end until the end of the video. You see now the full flight, manual flight. So we advance the thrust levers to take off. We need to stabilize first, then take off, go around. So we push the side stick or yoke down until 40, until 80 knots. We have 90, 100, 130. We want to rotate. So we pitch the aircraft slightly 9 degrees for rotation, take off rotation like this. So we have positive rate of climb like this. Let it gear up. We can leave the hands off from the side stick, no problem, as you can see as we climb, because it's well trimmed and it has maximum takeoff power thrust set. So you can see we're climbing, hands off, no problem. Only an aircraft can do that, flying hands off. So you can see we are 2,000 feet above the ground level, but 3,800 above the sea. With the airspeed 181 knots, the stall speed red in yellow 120. Need to pitch down the aircraft a little bit, climb with 4,000. You can see the green needle moving up. Also the runway heading. Also the terrain, red, green, yellow. Terrain around us. If we look around the data, the air data we have. So you can see the wind is this way. So we can use a little bit further. We see more terrain, green, red, yellow over here. If we look further away. This is the horizontal terrain map, also the flight plan, the waypoints we have to follow. Again, you see now the stall speed here, so we are here 5,100 feet above the ground, 5,200 as you can see. You can see the terrain below us with a green line as displayed at 5,700, 6,000 feet above the ground like this. So we keep climbing now the terrain. We are at 6,500 feet above the ground. This green line below us is the terrain, so we keep climbing. Also see the horizontal over here, and the vertical, the engine. So we need do other things now. We need to start the turn. You can see we keep climbing here. The lakes, very beautiful view over here. So we need to start the turn here for alignment with the flight plan, as you're gonna see. Use a little bit left rudder for left turn, like this. As you can see, we turn manually like this, leveling off here. Follow the next waypoint here, you will see in the map. Use a little bit right rudder now for the level off. You can see the air data now. We're following the airspeed over here, the stall speed right in yellow, the wind direction over here. Also the waypoints we need to follow. The intercept over here. So we have the intercept, as you can see, 5.1 nautical miles away from us. Also we have the indications here. This data over here from the head-up display. Also the autopilot setting. So we look outside. We have a very beautiful view over here with the Boeing 787. You can see the wings, very beautiful. Also view around over here, the Switzerland, Swiss Alps, the airport. Over here the Germany in front of us, the Bayern Munich, so we need to be overflying. We're gonna make a small turn again over here for following the flight plan. As you can see, we can follow the flight plan better tonight. We have more time, like 18 more minutes until we go home. So look over here the other display, as you can see. So we are here, as you can see. Make a turn over here, align with the flight plan. So use a little bit right rudder. Keep flying manually. We're gonna connect the autopilot later. You're gonna see also the autopilot use actually. So we can fly through some waypoints. We fly very good tonight. We have good follow-up of the waypoints and the LNAV navigation, as you can see. So this is the next waypoint. Zui over here. Negria now. We overcome the Zui, so we have the Negria. Is displayed in this side. As you can see, Negria is over here, far away. It's almost close to the DNI airport in Germany. So very DNI. Maldives. So we may overfly Germany for a while. As you can see, is in front of us. few nautical miles. So we have 17 more minutes left. Can actually overfly over. Or we can make a diversion. Gonna see how. So keep flying manually. So we are very close to the lakes, as you can see. So we overflying here, as you can see, Boeing 787. We have my homeland, the Germany over here, the Bayern Munich in front of you, the Switzerland, Swiss Alps, the galactic view. So very nice. Also the France in this side. So we overflying here the lakes. We may start the turn in a couple of minutes. 31,000, as you can see. We need to follow these waypoints, this flight plan. So we may make a diversion. It will take us like 10 minutes to overfly all waypoints. A little bit more. So we may come for a diversion over here. Back to the airport, overflying Germany, Bayern Munich over here. And we keep flying manually. As you can see, we have no autopilot connectors. We can make the turn manually like this, no problem. Can make more steep turn if we need. So here we are overflying the lakes, Germany, Bayern Munich, my homeland over here. The France behind us, and we have the frozen vapors. So we fly with the Boeing 787, as you can see. Flying very fast. Going back to the Switzerland, as you can see. Keep overflying the lakes over here. So it's a beautiful view of the Boeing 787. 23,800 feet. So we need to align with the flight plan over here. Keep a little bit more right rudder for this turn to make it a little bit faster. So we are 24,000 over here, leveling off. Reach a higher altitude. So we may connect the autopilot if we like. 3,000. So we can see leveling off, flight director on. We can connect the autopilot like this, so the throw left and right. Decrease the rate of climb over here. So now we have the autopilot engaged. Cancel a waypoint over here, so we're gonna fly straight to the zoo now. Over here, as you can see, leveling off a bit the thrust levers, switching off. So you can fly with over here. We can fly with the autopilot now, as you can see. The aircraft is flying autopilot. I don't use the side stick. So you can see the autopilot flying. We're flying with a little bit smaller airspeed. We don't need to hurry up because I need to explain a few things here. What you see in the displays, you see the autopilot. The AP is on, LNAV and vertical speed. So we climb with 200 feet per minute for the zoo in next waypoint. Over here you can see also the autopilot is connected from over here, this display. Autopilot on. Vertical speed. So we have this warning fusion, we don't need it. Also the engines thrust set for level of flight. So now we follow over here the autopilot, and we're going back home. We have like 10 more minutes left to go back. So we have a very beautiful view of the Boeing 787, as you can see. Galactic view, 24,382 feet. So we have the dark galaxy now, as you can see, galactic view. We leave behind Germany, the lakes over here, Swiss Alps, also the France. You can see the France over here. So this very beautiful view. You can see the Swiss Alps over here. So maybe we need to start the sun. Yeah, we need to start the sun now. So we increase the rate of the sun like this. Also the altitude set 1000 over here. We set an altitude above the ground level. The airspeed is okay, so we may also decrease a little bit further the rate of descent. So flaps up. Also fast levers a little bit more idle. Speed brakes. So we overflying here this area, as you can see. So we are descending using the autopilot again. We need to overfly these waypoints. You can see in the map, the terrain map over here. You can see the purple Mazda line here. Also the airspeed right now, idle fast for the rest of the descent. Also a little bit more speed brakes, as you can see. So we have 9 more minutes left. As you can see inside the cockpit also, beautiful view. And we have 16,000. Keep descending, disconnect the autopilot like this, keep descending. We're gonna descend through this way, as you can see. So now we're flying manually, as you can see. We have back manual, thrust and control over here. So this is the cockpit as we descend. You can see both sides. You can see the green arc is where the aircraft will descend to the assigned altitude. And now using this descent rate. So we have to cross also the Osnem waypoint, the wind direction also. So if we look outside, keep descending. We need to start out the turn now. As you can see, we are in a good position for approach. Also gonna use ILS localizer. Cancel the warning, we don't need it. So this is the turn over here, overturn this side. So we need to be aligned with this horizontal purple line for approach and landing, as you can see. Use a little bit left rudder. So this is the turn for approach over here, as you can see, approach turn. leveling off. Add some power for the level off over here, as you can see. So we almost align over here with the runway. There's a bit more left rather, if you fly manually. Have like 7 more minutes to go into the runway for landing. So we're gonna be having instrument meteorological conditions, IMC. We're flying through some clouds over here. As you can see, approach. Add a little bit more airspeed. So we are approaching. You can see also the displays here. The autopilot, the settings for the engine over here. So we have the Lszh localizer here. As you can see, we follow the glide slope. We are a little bit above the glide slope, so we need to descend a little bit. Also use a little bit left. Left alignment, landing gear down. Descend a little bit more. Increase the rate of descent. So we need to follow these lines for approach and landing. Flaps also, as you can see. So we're flying over. And we need to be aligned with the runway for approach and landing over here. So we're gonna have this view for landing. So we have a bit side wind gust over here. Is right rather now. We need to grab the airplane for approach and landing with a side wind, as you can see in one side. Use a bit more flaps also. Use a little bit more airspeed, thrust, commanded by the engines. So you can see, I just show you the Lszh localizer, how we follow. You can see we have some side wind gust. We need to grab the aircraft a little bit. A bit more idle for approach and landing. Increase the rate of descent over here. Keep flying manually. So we almost made it. We need to red and to white for the approach. We need to align with the center line. I'm gonna level off horizontally with the horizontal tail for the flare over here. So we're having the flare over here, very beautiful flare for approach. Very beautiful, very professional. Touchdown, as you can see, parking brakes and thrust reverse. We have idle thrust reverser. So we maintain a center line over here. Very beautiful, very professional landing, as you can see. We're slowing down. You can see the landing gear is fully safe. Thrust reversers. So we slow down. Keep slowing. So we made it. Very beautiful. Approach and landing, very professional. You can see everything inside the cockpit is safe. There is no breakages. All the systems. Also, you can see outside over here the landing gear. You can see all wheels are safe. There is no breakage of any wheel or any part of the landing gear here system. There is no broken tires. Also in the front. So this is the walk around of the aircraft. You can see in the front there is no breakage of the nozzle. Nozzle is perfectly well. We made very smooth the landing. You can see the forward nozzle here and the tires. There is no broken tires also. So this is the walk around after landing. You can see the aircraft is starting up. The weight should be over here in the runway. So this is very successful landing for a Boeing 787. You can see all landing gear behind it here again. There is no broken tires. So we're gonna see here, look around the airport also. Very beautiful view. The Zurich airport, the runway 14, the taxiway we can use. So we made a very beautiful landing, as you can see, very safe. All landing gear nozzle over here, safe. It will look a little bit more lights, maybe. Maybe more lights would look better over here for the runway. You can see the aircraft is safe. There is no breakage of any wheel or any part. A very beautiful landing. We need to reset out the autopilot like this. You can see the maps, everything is safe. We can go around if we need takeoff, go around and set the autopilot. So we have the thrust reverse here. We can disarm the thrust reverse like this. You will see the thrust reversers will be stowed. Again, one more time, thrust reverse like this. Full thrust reverse. You will see the reverse displayed over here with green. And now the thrust reverses are open. So we can cancel the thrust reverse and activate again. So that was Thomas Hatsios, the German-American pilot flying the Boeing 787-9 flight, jet airliner. So we made a very beautiful flight. Thank you for watching me. I'll see you next time. Bye bye. So bye bye. Thank you for staying with me for this flight. I'll see you next time. Bye bye.